Hey, it's Seth. Before we get started, I want to take a quick moment to mention a way you can support the Concrete Logic podcast. Whether you're looking to expand your concrete knowledge or want to keep the show going, check out the Concrete Logic Academy, concretelogicacademy.com. You can always make a donation directly at concretelogicpodcast.com. Any amount helps, and we truly appreciate your support. Now let's get into today's episode.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandett.
And welcome to another episode of the Concrete Logic Podcast. And today I have Greg Fricks, CEO of the Fricks Company. Today we're going to be breaking down what it really takes to design and guarantee a high-performance slab, why some floors fail before concrete even hits the subgrade, and the risk you take on when you pick one of or you design your own floor. So if you're in the industrial floor industry, concrete floor industry, I'm sure you've heard of Greg Fricks. You see Fricks floor in the specification sometimes. When it comes to, for me, I've seen it with cold storage projects. Greg, if you want to share more about yourself and Fricks, please do.
Yeah, so the Fricks Company is owned by myself, my brother, and my son, Ethan. We've been in business. Our father started the company in 1979, and somewhere in the mid-'80s, he started traveling across the country doing industrial concrete floors. Like most concrete contractors, we grew up in the business. We're out finishing concrete in high school and came into it in the early 90s full-time. And since that time, we established ourselves as a national industrial concrete floor contractor specializing in shrinkage compensating concrete, extended joint floors. We've been doing extended joint floors before anybody even knew what the term meant. So as to date, we've worked in almost every state in the U.S. other than Hawaii and Alaska, and that's more by choice, I guess.
Yeah.
For the logistics, that's who we are.
Yeah. All right. So today we want to talk about, that as we were talking before we hit record, we wanted to address a risk maybe some concrete contractors don't realize they're taking on when they decide they want to design their own floor, right? If you could kind of expand on that and your concern, and we'll go from there, and I ask questions as we go along.
Sure. So, as concrete contractors, we all take on a tremendous amount of risk, so much so that we've all become a little bit immune to that risk. We're just so used to dealing with it every day in, day out on every project that we do, that we kind of lose sight of how much risk we're taking. And then in my career, what I've seen, every time that there's a dip in the economy, whether it's a recession or just a slowdown, short-term, long-term, every concrete contractor is looking for an edge. When we start looking for an edge, we are taking on more risk and not even realizing that that's what we're doing. So whenever we go in, whenever we do a job, and I don't care if you're doing the paving, you're doing the slabs, the foundations, the walls, it doesn't matter. If you follow those specs to the letter of the law, you're following the plans, the specifications, and doing everything that they say to do, if anything goes wrong with that concrete at all, the concrete contractor is getting the first phone call. If that were to go into a lawsuit or any other complications, that concrete contractor is involved from day one and all the way through. The fingers get pointed at the concrete contractor as soon as there's a crack, a delamination, a scaling. It's the wrong color. It doesn't matter. That concrete contractor is getting the call. When you go in and you change the specifications or offer a solution or a different system to pour in the floor, the paving, or anything else, you're increasing your risk tenfold at a minimum. And now it's all your fault. Anything goes wrong with that slab, I'll say slab because that's what we do. That's industrial concrete floors is all that we do. So I'll say slab and floors many more times than I'll say paving. But these floors in these high volume distribution centers are very, very important to the operation for the life of that facility. So the customer expects everything to be perfect with no issues, no cracks, no curling. And they also look at modeling or discoloration as a problem because they don't understand in a lot of cases. And sometimes a more educated owner is more dangerous than a non-educated because they've had good floors, that they've had successes, and they know what they want, what they expect, and they think they know how to get there. But also, if anything is not what they expect, these big corporations they're out for blood, and their contract is with the general contractor, and then as a concrete subs, our contracts are with the general contractor, and in many cases, those contracts don't protect the subs to the level that they should. The contracts coming from the general contractor are written to protect them, and that's all well and good, and I respect that. But as subcontractors, not just concrete contractors, subcontractors need to learn how to read those contracts and manage those contracts to protect them just as much as it's protecting the general contractor. Like I tell a lot of our clients, and whenever I say clients, I'm talking about the general contractor because that's who we're working for. That is our client, and we respect that and want to work together. But when they put our name on that contract, that contract is as much our contract as it is theirs. And that's what a lot of people in this industry miss. That contract is there to protect both parties and the third party, the owner. But there needs to be as much language in that contract protecting the subcontractor as it does the contractor. And learning how to read those contracts, learning how to change language in those contracts, or in some cases, get some of that language taken out because it is so detrimental to the life of that subcontractor if anything at all goes wrong. So whenever we go in and we suggest alternate solutions to the floor system and our risk goes up exponentially, we need to make sure that contract is written so that we have the protection required. Yes, we need to stand behind it. Yes, that system needs to perform. And anything that fails because of our performance, absolutely 100% our responsibility. But that right there is the case I'm talking about. If that slab system fails that you have suggested or you have offered up to the general contractor and the owner, you're standing behind that. You're standing behind the concrete performance, the engineering performance, the load performance, everything that can and will go wrong with that slab is now on the concrete contractor's shoulders because he can't turn to the engineer of record. He can't turn to anybody else other than the proprietary system provider. And that's a lot of risk that most concrete contractors don't consider before they do that.
Yeah. I was going to say, since you're designing the slab, can we get whatever those designer agreements look like? Because every time something comes up on the job, not every time, I shouldn't say that, but a lot of the times if something comes on the job, there's never like you see a structural engineer raise his hand and said, "Oh, that was me. I screwed up and I'll take this one on." I mean, that is rare, right?
Yeah, I've never seen it in my 35-year career. We deal with a lot of great engineers.
Yeah.
We have engineers that design the loads for our floors, and they all do things to protect themselves as we do. Mm-hmm. And there's a lot to be learned. If you sit down and talk to an engineer and understand how they come up with their solution, you start to understand the risk that we're taking. And it helps you come up with a solution in your contract and helps you define the risk that you're taking as a contractor. These, what I'm going to call proprietary systems that are on the market. There's been a big push. We've been in the extended joint floor system world for 40 years. That's what we've done since the mid-'80s. And over time, there's been a lot of different systems that have come and gone from the market of people trying to compete with that jointless or extended joint system. And you have a lot of independent companies or companies that are developing a system and then going out to the market and selling that system to the end user and the concrete contractor. What we've seen is they've had the most success going through the concrete contractors and getting concrete contractors to sign up as quote unquote qualified installers of that system. Then they're providing all the materials that are going to go into that system, meaning the chemicals in the concrete, the reinforcing for that system, and the engineering. And in some cases, they're using different engineering methods that are not common in our industry, meaning they're using the Shinto or the Meyerhoff. And you can look into those. You can go on the internet, look up both of those systems and understand how they do the engineering. But the finite is the only one that does not accept cracks. The Shinto and the Meyerhoff, in those engineering solutions, they accept cracks. I've never met a client that accepts cracks. And in those two engineering methods, what they do is they accept warping. And when you accept warping in concrete, you're going to get cracks because concrete does not warp. Rebar warps, but concrete does not. And whenever you bend concrete, it cracks. So you have all of these different things that go into this proprietary floor system, and they're selling that to the concrete contractor. And then the concrete contractor is convincing the general contractor and the end user to buy this extended joint or controlled jointless system. Now you've introduced another party into that. So anything goes wrong with that floor, there's multiple fingers to be pointed. And who's going to stand up? What is at the end of the day, how much water does that warranty carry? And is everybody trustworthy to come into the table and help solve the solution? In most cases, or a lot of cases, the concrete contractor ends up being hung out to dry. And I encourage every contractor that's going to take on one of these systems, I encourage the concrete contractor and the general contractor and the owners to learn everything they can about it and do their research to find out what problems there's been, because we all have problems, and how did those problems get solved detail-wise? How was it? Were they fixed? Who ended up taking care of it? And how much pressure had to be applied to get those fixes taken care of? And then the concrete contractors, I encourage every concrete contractor in the world to learn all that they can about their product. Learn everything that there is about the system. Do testing. Like when we do a floor, the rock, sand, and cement is sent to us, and we put them up and do mix designs. We test it. And you've got concrete contractors out there installing systems that they've just heard about, have never seen installed, never even seen it in a finished state, that are going out there and they might do a test pour the day before, but then they're pouring, 20, 30, 40,000 square foot at a time, and they've never even worked with that design. And a lot of the extended joint systems are putting a lot of products in that concrete to get it to perform the way that they've designed it to, whether that's shrinkage reducing admixtures, retarders, curing agents. There's a lot of different things that, as you well know, Seth, that can go into that concrete that can drastically change everything about all aspects of the performance of that concrete. The fluid state, how it's going to be poured, the finishing of it, how long it's going to be cured, the shrinkage, the curling. There's a chemical for everything that you can imagine to be put in concrete to perform the way you want it to.
Yeah, even things that you don't need.
Yeah.
Yeah, those are excellent points. By the time this one comes out, we'll release another episode about this exact subject about the shrinkage compensating concrete mixes and things like that. So this is great timing. So a couple things with your floors or any other extended joint or jointless floor, are you taking on a maintenance program as well when you put these floors down? Or, is the warranty period longer when you put down a floor like that? What else is the concrete contractor maybe signing up for they don't understand?
Well, in most cases, for what we've seen with the extended joint systems, the owner's requiring a 3 to 5 year warranty.
Okay.
And the way that we put it is that the joint fill is only warranted for 1 year if maintained by the owner. Because we look at the joint fill, that is something, it's almost like the oil in your car. It's got to be changed. If you don't maintain it and you don't change it, the engine's going to blow up.
Uh-huh.
And if you don't maintain the joint filler, whenever it's not performing, then that joint will start deteriorating. That joint's going to blow up. So our warranty is written that the joint fill is 1 year if maintained by the owner during that period. And then we do a 1 year walkthrough. And then depending on the client or what's been negotiated, our warranties are 3 to 5 years. I know that most of the proprietary systems offer warranties, but I would encourage you to take that warranty to an attorney that you trust and get them to read it and see that you're going to get the protection that they are proposing that you're going to get.
Mm-hmm.
We're all, if you spend any time at all reading contract language, it takes time to learn how to read between the lines and see what they're actually trying to get to. We were reading one, you've had some podcasts recently about AI and using AI to your advantage. We had some language recently that was very confusing. So we took it and put it in Chat GPT and it broke it down for us. It's like, oh, wow, it says that? Well, that doesn't help. That's not good for us. So it's taking the time to learn how to do that. And I strongly suggest that anytime somebody gives you a warranty, to spend some time reading it and understanding it. If you don't understand it, get somebody to help you learn how to read between the lines.
Yeah. So warranties a little bit longer. I mean, if you typically on a normal job, say, you just go by the specs and the drawings, a typical warranty is a year long. So, right, you show up a year, short of a year, walk the job, they give you a punch list, you fix anything if there's anything that needs to be fixed, and then you're off the hook after the year. So when you're designing your own slab or taking on somebody else's design and replacing what's in the specs and the drawings, just recognize that you're taking on a longer commitment there as far as with the owner. And then also with these proprietary designs, is there other costs that maybe concrete contractors aren't aware of? Is there other insurances that you may need to get or anything like that is atypical of just going by drawings and specs?
So let's address the comment that you just made after 1 year off the hook. Technically speaking or contractually speaking, yes, once the warranty ends, you are quote unquote off the hook. Uh-huh. But your reputation isn't. Like what I like to say is that floor carries our brand for the life of the facility. And if that floor fails after 1 year, let's just assume there's a 1 year warranty. If it fails after 1 year and we don't go back as concrete contractors and take care of that or help fix the issue or come up with a solution, then that damages our reputation, damages our brand, and that keeps us from getting the next jobs down the line. And that can hurt with that end user and that general contractor that you're working for, that you have that relationship with. He's dealing with multiple owners that now you may not have a road into because you did this one job for this one owner, this one proprietary system that's not performing, and you didn't go back and take care of it, even if it's after the warranty. Mm-hmm. And any good contractor, and I don't care what trade that is, any good contractor is going back and taking care of issues after the warranty period within reason. Yeah. So with the proprietary systems, getting the contractors to understand what's in it and how that's going to perform. We do 90% of what we're doing is design build, and we're working with our engineers doing that. Especially in the developer-based properties, they're always trying to come back and change the rack configuration. We're given the point loads and the live loads, and we design the floor for that. And let's just say it's an 8-inch floor based on a single rack, 5-level high rack system. Then the client that's going to take over that facility and stock that facility wants cantilevered racks. Well, that drastically changes the point loads. And in most cases, now that to carry the same amount of weight, that needs to be a 9-inch floor to handle that cantilever rack. And it's amazing how many times they try to cram that down our throat and get us to sign off. Because we've been educated, because we understand how that works and the risk associated with that, we will not do that without the engineer being involved. Then you need to understand that. You need to understand the engineering behind the system to carry the point loads for that facility. Then how are the joints treated? Because a jointless system still has construction joints. You still got construction joints at the door, thinking of a cold storage facility. And if you've got a 500,000 square foot dry storage facility, the most you're going to go is 200 feet, and then you're going to have a joint. Well, with conventional concrete, you're still going to get curling, and that curling is being pushed out further. And the further you push curling out, the greater the curl factors are. And that occurs at the construction joints. If you don't have proper load transfer devices there to handle those loads, that joint's going to deteriorate very rapidly. Are there armored joints there to protect that joint? How is the joint filler going to perform in that? Because in some cases, if that curling is so drastic and the shrinkage at those joints is so drastic, the joint fill won't make it a year, especially if you put it in too early. But even with the owner trying to maintain it, that joint fill is going to fail, and you're going to have to be in there replacing that joint fill or touching it up, but more than likely replacing it. Mm-hmm. So it's understanding how are those joints going to perform and what is there to protect those joints for the life of that facility.
Yeah. So going back to your point about the warranty and fixing things that may come up beyond the warranty period, I think your point is well made, and it doesn't even, I think that applies to not just your proprietary systems, but also your normal traditional build by spec, the specifications and the drawings. So you know what you're putting down and potential issues down the road. So but I think I would say a majority of the concrete contractors out there aren't digging into that, right? They're going through the motions and doing hey, we got a job. Let's get the smiddles done, get them pushed through. They need us to get started on a certain date, and it's coming up on us quick. We don't have time to actually study what we're actually putting down. I mean, that's a great risk that you're taking on blindly, right? You're not You're not studying the materials that you're using to put down. And then going back to I'm sure in your business, you've come across these developers that are doing these speculative buildings, right? They don't have a tenant per se.
Right.
They want to build a cold storage facility, and then they may have one tenant or multiple tenants that are going to use that facility. They changed like you said, the racking system or whatever. And I imagine you would have to, if you're, using your design, that you kind of have to spell out, hey, this is the floor that we're installing, and this is what it's designed for, like an owner's manual, and to hand it over to the owner and say, hey, this is what we gave you. If you do anything beyond this, it's on you.
Absolutely, we do.
Yeah.
Yes, and the whole developer-based cold storage, that was a whole new market for us, and is a learning curve for us, because we've never had an owner come back and say, hey, we're going to completely change the racks. They move them, we've had them moved. But to come back and say that, hey, we're going to change the configuration of the racks. And a case in point of what you're talking about right now is we have one job for a client that is 8 inches, and now we're doing a new facility, same point loads, that has to be 9 because the soils aren't as good. Mm-hmm. And that developer is up in arms going, no, we want 8. You have to do 8. Okay, we can do 8. That's great. But we can't meet the same point loads that we did on the previous job. Mm-hmm. And he doesn't understand that, or maybe he does understand it. He's just trying to cram it down our throat. Mm-hmm. But it's having the education and the knowledge to stand up to that and prove up why one is 8 and this one has to be 9. And then whenever they call up and say that they want to go from a single pushback to a double pushback, explaining to them, being able to explain to them how those point loads have just changed drastically, and you're not going to be able to put as much weight.
So just to kind of summarize what we're talking about today, if you're considering using your own design or a proprietary floor system that someone has asked you to get certified to put down, the steps to kind of mitigate your risk would be first to test pores. Sorry, getting up.
No, I'd say the first steps is learn all that you can about it. Do your research on it. Don't just sign up for it. Certainly don't pay the initiation fee until you've done enough research to find out what successes they've had with it and what failures they've had with it. It's human nature to just look at the negatives and research that. Well, some of these have been successful, but where have they been successful? under what circumstances have they been successful? And also, what part of the country is it? You know, a system that works in Chicago, where the ready-mix materials are very forgiving, is not going to work as well in Southern California, where you have extreme environment and extreme dry environment, and the concrete materials in that area are high shrinkage. So that proprietary system that performed very well in Chicago or the Midwest is not going to perform the same on the far West Coast. So it's understanding what successes and what failures they've had. And whenever there was a failure, how did they get involved? What did they do to help mitigate those problems? And then also, if you sign up for it, learning everything that there is in that concrete and doing test pours way before the job starts. Most of the time when somebody's taken on a proprietary system, they're also the total package concrete contractor on the job. Place that system in some areas that just don't matter. I mean, in mud slabs or an area that you could tear out, or in office areas that you can get covered. But try to place that in other areas so that you can learn as much as you can about it, and then try to get the proprietary developer of that system to tell you everything that there is in that concrete and how just a temperature change is going to affect the performance of that slab. Yeah. Because if you're, right here in Texas, we were running, the temperature was in the high 40s, low 50s, and then all of a sudden in 1 week's time, we shot up to 103 in just 7 days. Well, that drastically affected the performance of the concrete that day and actually the next few days following that. And if you don't understand the system, you don't understand what's in that concrete, you're not going to be able to adjust it accordingly to get the same performance.
This was great, Greg. I think you brought some great points up today. And if folks want to reach out to you and learn more about Fricks, what's the best way?
Either go to our website, or you can get me on my email at gkf@fricksco.com.
All right. Greg, thank you for coming on the show today. I appreciate it.
Yeah, thank you, Seth. I appreciate you inviting me on the show. I've really enjoyed listening to your past podcast and feel honored to be a part of this. So thank you.
Thank you. And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit ConcreteLogicPodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood, iron, and mud. We work hard for $1, give thanks to the Lord.